Hey everyone, I thought I'd make a little video because a few people in the CAD class were wondering how to make 3D renditions of flat, two-dimensional orthographic views, third-angle projections. All I'm doing is taking the stuff that we've done in class in two-dimensional views, third-angle projections, and modifying them into 3D objects. So let's start simple. You want to make cylinders to start because that's a good shape. Basically, a cylinder is an extruded circle. You have a circle, you pull it, and you stretch it out. So what we're first going to do, we're going to go back to the original view, which is the one you should be in. All right, we're in a top-facing and two-dimensional view. So what we want to do, let's start with the crank pin just because it's simpler than the chamfered one. You grab it, you copy, you move it, you move the duplicate over here. Then what we're going to do next is switch to the 3D basics or 3D modeling. It does not matter as long as you switch. So that's on pressing the gear causes the ribbon on the top left to change, and you'll see different commands now. But we're going to use the commands by typing them. The very next thing you want to do is select the circle. And then you click on this view cube. You click not anywhere, you click on the bottom right. And by having the circle selected, it's going to change the camera view to a 3D camera view that is focused on the subject, which is the thing that you have selected. You have it now, and you know that the crank pin height is 42. So you extrude. That command is also present in the ribbon, but we're going to type it in. Extrude. Cool. And now you notice you selected it. If you pull downwards, you extrude downwards. If you go upwards, it extrude upwards. And you're gonna just at least be anywhere on the upper side and then type in 42, not 24, 42. Bam, you got a crank pin. That's as easy as it gets. Make sure that if you want to look around your 3D model, you have the model selected, because otherwise it goes crazy. You just wanna have your subject of interest selected while you navigate. That way the camera always knows what to look at. Otherwise it gets confused, and then you have to zoom back into your view. All right, that's one. Now we're going to make this one, which is the crank. No, that's the gudgeon pin. Yep. So the gudgeon pin, as you might know, it's a cylinder with an outer diameter of 8 and a height of 24. So we're not going to focus on this inner side yet. What we do is first extrude this shape. So you copy it, you select it from wherever it is, you move it out to an area to work on it. So we have our 8 diameter circle. We're going to extrude it to a height of 24. Same command, extrude. Specify the height. Again, upward. Type in 24. Now we're almost there. All we got to do now is make the chamfers. For the chamfers, we're not going to use a 2D command or do any sort of manual tricks. We are going to use a very simple 3D command, which is called chamfer edge, which offers 2 arguments, loop or distance. We're going to use the distance one because we know that it is 0.5 times 0.5 for the chamfer, which amounts to creating a 45-degree chamfer. So specifying the distance, let's type in distance. You can type in dist or the whole thing. Distance 0.5, that's distance 1, so that's one of 2. Now it's specify distance number 2, so that's the second one, also 0.5, which again amounts to 45 degrees. Now we zoom in a bit and we highlight the edges we want to chamfer. As you can see now, it becomes highlighted. Bam, that's 1. See the bottom one? Bam, that's 2. Now you have chamfered your gudgeon pin, and that's it for basic cylindrical shapes. Yep. All right, so you've now made 2 cylinders, and one has a chamfered edge. It's possible that you have your 3D visual style set to a specific setting, which is not what I have. It's possible that you started out with 2D wireframe or something else. 3D hidden is one that I like. And hidden, yeah, they're the same essentially. They're nice because they give you enough information about it without getting all the bells and whistles of something that's a bit more fancy, like this, for example. It's cool, but I like keeping it simple for now at least. So you have this, and you can tell that it's two different shapes that are three-dimensional. Cool. Remember to always grab models when you navigate the camera around it with the view cube. All right, deselect that. We're gonna step things up and get to the next level, which is the connecting rod. Here it is. This one takes a bit more work, but it's quite satisfying to make. All right, so we get to the model, and all right, let's get back into the top view. Grab the stuff first, then click top view. Okay, if you are in the wrong angle, the wrong orientation, you click on the arrows on the top, the curved arrows, and that will rotate the whole view cube, the viewpoint, to make sure that you are upright. So you have this. That's cool, but you gotta now be a bit more careful as to what you select, because there are all these dimensions in the middle of your thing. So we're going to, this is my duplicate. I would highly recommend creating a duplicate, and so make sure that you don't work on the one that is already used for the layout. So you go to your duplicate, grab all the dimensions, get them out of the picture. You don't need them, as well as center lines, any sort of annotation really. Yeah, that's good for now. Yeah, I would even surmise that this stuff for now is not gonna be useful. We have the information on our duplicates, so we get rid of it. Really, we want all the stuff that is actually going to be extruded for now. Extrusion is in of itself quite easy. It seems like I still have like specs and things here and there. So now it's clean. You have a clean model to then apply 3D functions on. All right, well, you can copy it and move it if you want to make a duplicate. In my case, this is already in of itself a duplicate. So I'm going to work on this. Get rid of that top view as well. You have this. You know the drill. Grab the thing, go to the bottom right. Now you have a three-dimensional view of your model. And now we're going to, with the model selected, type in extrude. Yes. And now we know that the height of extrusion is 8 based on the other dimensions. So you see here, we're going to extrude upward by the number 8. Right, you have the thing, it's here, and it looks cool, but there's a lot of stuff going on. So we're going to simplify the shape by saying join, and now I think it's that, or it is group. Cannot go wrong with group. Now it's one shape. If I click anywhere on the shape, the whole thing is selected. It allows for a bit less of a headache. Now, there might be a problem in the extrusion. I'm gonna check a different shading. Yeah, okay, so this is a problem I have right now. All right. So what I should have done is actually first join, then extrude, because it was not a closed shape when I extruded it, causing it to consider the edge to be its own enclosure, and the inside of the shape was left out of the calculation, and now we basically have just the walls, and that's not what we want. So let's go back. I'm going to cut here, and this is how not to do it. All right, so if you've made the mistake of extruding before having ensured that the shape is unified by using the join command, go back through your steps, undo, 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 until you're right back to this stage, which was where I went wrong. As you can see, I have all these distinct line segments, and what we want to do is that anything that is meant to be part of the same shape to be joined together. This will allow the extrusion to not create, to not be misunderstanding of what we're trying to work with. So we have this, you grab everything, then use the command join. Now we have 4 distinct shapes, 2 circles, a trapeze in the middle, and the external bone shape of the connecting rod. We're still in this 3-dimensional view. That's going to change in a bit. We're going to select the trapeze first. Let's start with the trapeze because it's a bit more intricate. As you might know, by pressing distance or by measuring and doing the dimensioning, the trapeze in the middle is, so the whole thickness is 8 millimeter, but we want to dig out 3 millimeter on top, and we want to dig out 3 millimeter on the underside. For that, we're going to use the command subtract at some point. So we remove from the 8mm, 3 on top, 3 underneath, leaving 2mm in the middle right here. All right, so, but before we do that, we want to have at least one of the two trapezes extruded. So we're gonna do extrude, and 3 is the height of one side of the trapeze. Cool, so we have now extruded the trapeze. The trapeze is one of two instances. We have the bottom one and the top one, like a sandwich. So you have the bottom bread and the top bread, and we'll leave a gap in the middle. So we get back here, and then what we want to do is copy and specify a base point anywhere. I would recommend using something easy to refer to. Click, and then click again, enter. I believe that now we have duplicated the shape exactly where the original is. Seems like it. What we want to do next is displace the copy that is fused with the other one, overlapping, superimposed, whatever you may want to call it. You highlight the trapeze, and then we're going to displace it upward. So depending on what you've currently got as a thing in the middle, you'll see this thing here, right? This sort of the Cartesian coordinate thing. What we want to do is to right click at the very center of that blue intersection, and when you do it properly, when you highlight it, it should be orange. So let me try again. You see, here's my cursor, and if I get onto that blue diamond shape and then right click, you see move. You can choose also rotate and scale, but we want to move, so we have this. What we then do is click on the blue one, because blue is Z, hold it down, go with the cursor somewhat upward, then press 5 because 3 of the thickness of the trapeze plus 2 for the gap should mean that when you face it frontwards now, you've left a gap of 2mm in between. So remember how you hold on to that model and then click front or corner or top to navigate between the different types of views. We have this. So this is actually what will be subtracted, but for now they're the positives. And then once we have the rest of the shape, we will select these things and remove them from the pre-final model. So we have these two things. Now what we want to do is the two circles. Actually, now we can do all the rest. So grab all three things. Bam, bam, bam. Now what you want to do is extrude and give it an upper height of 8, which means that things were done properly because my upper trapeze lines up correctly with the rest of the shape. Do not forget to always highlight the object before manipulating the view cube, because every time you don't, you will be zoomed completely out of your view, and it's a real pain to scroll back into where it's happening. So you have this. It's cool, but it is if you give it all the color, it's not exactly the final result we're looking for. We have a solid thing, and we want to have subtraction of the negatives. So grab everything that needs to be removed. In our case, the two circles and the two cylinders and the two trapezes. So it might be a bit of a pain at first to find the things. I recommend changing views to something a bit more pure, like hidden or the wireframe. Wireframe is a bit complicated. The best is really hidden. Cool, so we're making progress with the connecting rod. We've extruded it, including what will be subtracted. Let's do a little recap. Make sure that you are in the visual style that is called 3D hidden. And to get that, if you don't remember, you go first to 3D basics or 3D modeling as a setting instead of the drafting and annotation. So, you go back to your gear and select one of these two. All right. So you selected 3D hidden or hidden. Now that we've got this, we want to perform subtraction. We'll remove the 3 ones that are currently facing the top. So subtract, select object. The first part of the command of subtract is asking about the positive, what will remain at the subtraction. So you say enter once you've selected the outer bone shape of the connecting rod. Then you press enter. then you select the inside, and for the inside you highlight and click on the inside of the shapes. Right? We're gonna for now subtract just the upper parts, and then we'll do the underside. Here we go, double enter, and now it's removed. As you might see, let's select everything, and if we navigate, you can see by navigating that we've hollowed out the two circles, the two cylinders, and the trapeze in the middle for the top side of the trapeze. You might be able to notice that we have yet another trapeze in there that needs to be subtracted. Let's select everything and then go to the underside. We're on the underside. You can see now it's still there, indeed, as it is flush with the shape. You subtract once again, so that means first selecting the exterior shape, the positive, press enter. Then you select what needs to be subtracted from that positive. It's a bit finicky, but yeah, here we go. Take your time with this and take as many attempts as you need, you know. And then you press enter, and then for some reason press enter again. And now you will see that it is one shape. So we've hollowed out the underside, the upper side, and of course the two cylinders on the right and left side. And that is some progress with the connecting rod. Next step we're going to do is the countersunk hole. All right, before we move on to the countersunk hole, one valuable tip when working in 3D is to select the model, place it in a fashion that is neat and easy to recognize, and then we're going to right click on the view cube and then set current view as home, so that whatever you do, whatever you manipulate, whether it's around this object or another object, you can always click on the house, the little home logo at the top, and it will send you right back. And that's going to be really useful now because we're going to travel back to the original design. So I'm going to scroll out and into the drawing to the place where I have my original copy of this, which is the third angle projection version. And here we are at the top view. All right. So we are back at the third angle projection with all the dimensions, with all the stuff, with all the views. And we're doing that because we need to remember what are the dimensions for the countersunk hole. For the countersunk hole, what we have is, in my case, maybe not in yours, but in my case, we have 2 millimeter diameter for the cylindrical hole, so like the prolonging here, that is 2 millimeter in length. And then we have this dimension. This is a custom measurement I've made. I have ensured that my countersinking is at a 90-degree angle, so it's still at the right position at 46.77, but the conical thing is at 90 degrees. And I checked online, and some of the ISO standards for countersinking are 90 degrees. So that's why I did that. Knowing that, we are going to fly right back to where we were previously in the model, at the 3D model. And because we've just saved the view with the home, we can go right back to where we were. And now we're going to do the actual countersunk hole. All right, so we have now traveled back to our 3D model. In order to create the countersunk hole, which will be subtracted from the big shape over here, we're going to make it a positive first and then perform the subtraction. I'm laying down a line here so I can easily see where I'm putting down the circles to be extruded. I am making a circle of diameter 2. Make sure that you're using a circle diam, or if you're doing a radius, make it half the value of the diameter, obviously. And then you do a second circle on the opposite end of this line. It doesn't have to be too big, but it has to be somewhat bigger because it's going to converge to a point which is going to be resting, where it's going to be where the cylinder is going to rest on top. This bigger circle is the cone, the future cone. Extrusion, we're going to start with the smaller 2 millimeter side, and we're going to pull it up. Not too much, not too little, because it needs to be long enough to poke through, but not long enough that it pokes through to the other end of the shape. So let's say something like 7. Now we go to the other side and we're going to extrude as well, but with a difference in how we do it. Instead of pulling straight like this, we're going to type in taper. Now it's asking us for what taper we want for this extrusion. We want to do something of a value 45 degrees, because 45 degrees in taper is equal to a cone angle of, depending on how you see the math, but if you do 45 here, it equates to 90 degree viewed from dead on. So I'm going to type in 45, and then I click anywhere higher than this, because if I go lower, it's going to cut down. All right, bam. Now we have the two shapes. What we want to do next, I'm just going to prove that this is in fact 90 degree viewed from the side. I mean, you can bring a protractor if you want, but this is pretty much 90 degrees. It is definitely 90 degrees viewed as an angle. Going back to that view like this. All right, so we have the two extruded parts, the cylinder and the cone. Now what we want to do is fuse them together. The first step for that is to make them converge to a single central point. I have said earlier that I recommended switching to a view where the other side of the model is hidden, but now actually we might actually be better off with wireframe so that we see the line where the two models converge. So now we're in 2D wireframe. Also, I recommend ensuring we're back in 3D basics. And now we're going to do move. We grab the center of the cylinder over here, then move over here and put it where the center of the cone is. And now they should be converged. And I'm going to switch to another view to show that. Okay, it looks good. Yep, as you can see, it is in the middle of the thing. All right, let's go back to that top front view. Yeah, top front right. Okay, so we're here. Maybe let's just bring up, using the blue arrow for the Z axis, bring up the cylinder a bit so it sticks out enough. We can now delete this line, and now we're going to put it inside the connecting rod. For the next part, we're going to first join together the two components of the countersunk hole, positive version, and then we're gonna rotate it and move it into place so that it is lined up where it needs to, so we can then subtract it from the overall shape. First thing we're gonna do is grab 1 and 2 parts, and then we're gonna use the function group, not join but group. By holding down shift, you can actually lock in. Now I'm pressing shift and it wants to position like that, and that doesn't work.
That is why you fail.
So I'm gonna try again. Cool, we have combined the two shapes into one by using the group function. Now we're gonna rotate it, and in order to rotate it, we are going to type in 3D rotate, and for the base point we're gonna say whatever, let's just say here, and then we're going to say rotation axis. We're going to select the rotation axis, and that is going to be the x-axis because that's the red one, so that the cylinder points towards the connecting rod. So I'm pressing shift. Does that work? Yes. Okay, by holding down shift, it's kind of like magnetizing it to 90 degree intervals. All right, so it's pointing towards the connecting rod. Now what we're going to do is grab the thing again and rotate it on the z-axis. So you click, hold, and then while holding it and slightly being on the side that you want to rotate it towards, you type in 46.77, and now it is pointing towards the appropriate position. Okay, now that we have oriented it through rotation commands, now we're going to move it in position using the move command. But before we do that, it might be worth getting the blueprint so we can compare to the blueprint. So we're going to zoom out of here and grab a copy of the original blueprint. It's over here, so grab the whole thing like this and like that. CO for copy, click, then press on the home logo, and now you brought it all the way over here. And that's going to be a bit handy because then you can place it right underneath the model. Cool, we place the copy right underneath the model. What we do next is switch back to wireframe visual style so that we can see right through the model. Next, we click on the model itself, the big connecting rod 3D version, and then press on top and ensure that we're in the right orientation using these curved arrows on the top right side of the view cube. We're here, we have a 3D model, we have the hole. We're gonna now just kind of wing it by moving it in place. I know this is not exactly proper, but maybe it snaps in position. Ideally it would. All right, so for that I'm gonna grab the converging point of the cone and the cylinder and kind of place it where it just feels right. So just about here. Bam! Awesome. As you can notice, a lot of the cone sticks out, but that's fine because it's gonna disappear once we do the subtraction. So now we take, I know it's visually a bit busy right now, but not for long. All right, let's just grab the cone and then click right, bottom right of the top flat side, zoom out. All right, while we're back in this view, what we can do is get right back to 3D hidden. Now what we do is perform the subtraction. For that, subtract, select the big shape. This is what we're going to subtract from. And now we're selecting what we will subtract. So you click enter twice, then you select the other object. So in this case, what we are using to subtract, and you press. And now if everything is well done, you should have a hole that is at the right place. In my case, it's not. And I don't know why.
Fix it, fix it, fix it, fix it, fix it, fix it! Fix it, fix it, fix it!
Cool, so you got to this point. You've placed it using the top view cube position and aligned it so that it is aligned with the blueprint version. Now, it might look like it's ready to go and ready to be subtracted from the main shape, but if we change position to a front view, we notice that it is in fact too low. In my case, it lines up exactly with the orthogonal plane for the XY. So what we're going to do is move it up, of course. So we're going to perform a move function, and what we're going to say, instead of specifying the base point and moving up manually, we're going to just, there's only one dimension we need to focus on right now, which is a Z dimension. So we type in displacement in the move command, which gives us this option of the 3 coordinates 0, 0, 0. We want to only interact with Z. So we do 0, comma, 0, comma, and 8 divided by 4, which is the half of the height of the thickness, is 4. So we type in 4. And now it is exactly where we want it to be. So now we finally get to my favorite part, the subtraction. So maybe let's get into a nice view for that. Let's switch to a different visual style. I recommend 3D hidden. Alright, so we're going to perform subtract. Deselect everything, type in subtract. Select the object that you want to subtract from the main shape. Enter. Now select the object to subtract, the cone plus cylinder, aka countersunk hole. You press enter, and now if everything went correctly, we have the exact shape that we need. Now it might not be lined up exactly the way Peter Bertram's projection line made it look, because I might have placed it just a bit off or something, and so the ellipses are warped in a different way. Doesn't matter, this is just for illustration purposes. Plus we're not going to present it in the same way, because we're presenting it in a position that is isometric view. Right. Before we get to the next part, I'd like to show you how not to do things, because I've been playing around with this for a while and I haven't always learned things the right way. In my case, I have been trying to get a 3D model to be represented in an isometric position within the same viewport as the flat models, the third angle projection blueprints. And the problem with that is that what you do is actually manipulate the object by performing 3D rotations in order to approximate an isometric view. And the problem with that is that I don't know exactly the rotations, the degrees, the ways. Honestly, it has been quite of a nightmare. I've been spending up to 30 minutes trying to get things to look almost right, and then realizing that it even right now, if you look, you'll see that it's not technically isometric. It's a bit angled, like it's tilting towards us. So in order to not have this problem, we're going to have a different approach. So this is our current project, our current version, and what we're going to do instead is create a separate viewport within the layout. So don't worry about that side view. I'm just for now cropping this so that we create some space in the top right to allocate space for a viewport that will be dedicated to a different camera. And so we're going to copy this and place it here. Now we have a copy. We're gonna resize this layer, this viewport, okay? And before you do anything in terms of resizing this and deciding, oh, I want to already do this, wait, don't do it. Because what we're gonna do next is moving this. We're going to move the model out of the way, someplace safe where the blueprint visually will not interfere with it. Then we go back to the layout. We move to the right. Right, one more thing. You might see on my bottom right, I've locked my viewport. And so what you want to do is unlock it. And then once you've unlocked it by clicking on the padlock, you should be able to pan the camera up until you find the model in question. Excellent. Then you zoom out because, okay, here it is. Now I'm going to double click away from the place. Oh, escape, then double click. All right. Right, so we have two different viewports. One is currently unlocked and one is locked to the 221. So if you want to know how to do this, you select your scale, then you click on the padlock, and that prevents you from scrolling and messing up the scale by creating these crazy irrational numbers. So once you're back here, you have the model. Bear with me as we apply one rotation by 90 degrees on the model, and then we do the rest with the camera. So we are going to first head back to the model, zoom in on the usual suspect, and then go back to our top front right view. And now we're going to do a 90-degree change in the position of the thing. Cool. And what happens if we now head back to this? All right, so it's now laid flat on its side. What we then want to do is double click here, and then let's try select the model, then click. Let's try the opposite side. I think we're almost there, guys. Yeah, I had it. Yeah, just confirming. All right. So now this is in the correct position. We know that because all we performed for an operation was a rotation by 90 degrees. So it lays flat in model view, but in its viewport in the layout view, it is rotated by 90 degrees in a different direction, which amounts to laying this in an isometric position. And so now it should be good to go. We're going to resize this back to where it was, and now we have a isometric view of a 3D model combined with the rest. I'm going to check what it looks like when we plot it. MP-Eng-Tech, choose DWG to PDF, apply to layout, preview, and now without the layout stuff, it looks pretty good. The only thing is it seems that there is some interference with the top line. I'm not exactly sure what is going on, but yeah, for the most part this looks pretty much what I was hoping to show you today. So yeah, hope you liked it. Cool. Talk to you later. See you in class.